Hey, it's Joel. I've got a surprise for you. It involves 3D printing really quickly with Taylor, who you've seen before. Hey, buddy.
Good to see you again, Joel.
Good to see you again, but where are my manners? Welcome to 3D Printing Nerd Studios, proudly powered by PCBWay, PCB, CNC, and 3D printing. It's all at PCBWay.com. And 3D printing is what we're talking about. Like I said, really fast, open source, resin-based, computed axial lithography. Did I get that right?
Yeah, it's a bit of a mouthful. Computed axial lithography, but
computed axial lithography, man.
You saw us about what, 2 years ago? Was it?
It's been a minute. Computed axial lithography.
Yes, it's a magical technique. It's what's called a volumetric process. So most 3D printing processes build up layer by layer.
I'm very familiar with those.
Yes,
obviously.
of course.
Yeah.
We do something a little magic. We do volumetric printing. So we form every part of our geometry all at once. Because it happens, we print very, very fast because we're forming the whole part at once.
Right, you're doing it, it's not like, okay, traditional additive, if we think about an FFF process, we're forming the first layer and we're going up in Z or Z. You were just like, I'm just gonna print it all at once.
Yep, it's just gonna be there. We're just gonna form it. So for example, I have a little space shuttle in here. This was made in 20 seconds.
20 seconds?
20 seconds. So we don't need time to, like move the layer up or like start the next one because we just do everything at once. So everything is very fast.
It is a viscous resin that's been oxygenated and it spins as a projector is throwing 2D images with 3D information in it.
Yes, it's actually pretty simple in concept.
And now we're taking the show on the road. So through the last 2 years, there's been a lot of students working on some awesome things here. So all those technologies you saw in the lab, we tried to boil it down in here. And this is what we call OPENCAL.
OPENCAL.
Open Computed Axial Lithography.
But it's really cool to think about because a couple years ago, like it was a room. But it all came together and it made really cool stuff. And now all of a sudden you put this in a Pelican case, checked it on an airplane and brought it to Seattle.
Yeah, now it can fit in checked luggage. There was just so much excitement from the community around this. And we're just like, we have to bring this to everybody. Everybody has to have a chance to try it. And of course, there's caveats. It's still a research technology. But these how these technologies start. You start playing around with them, you grow it. I assume people are going to make amazing advancements just by getting involved with this. We're really excited for it.
Well, I think being open source, right? There's a bomb for this and people can build it themselves. A lot of times people don't get excited about something unless they get to tinker with it themselves. And that's what you're doing with this.
Exactly, yeah, that's just how technologies grow, especially like emerging. We've seen that with the 3D printing technologies before.
Sure.
We saw that with the RepRap. That's kind of how this whole desktop 3D printing kicked off. And we think we can do the same thing with this. So
wow.
Everything here is made to be essentially made in a makerspace. Even just with 3D printers and hacksaws and hand tools, it looks really shiny with all these laser cut panels. Those are optional because we really want it to be as accessible as possible. And the awesome thing is that there's other components in other communities that are coming together to support this as well. So our material in here, as we've talked about before, is a special material. It's not like it's similar to other SLA or resin technologies, but it absorbs light really more gradually and carefully.
Right. Yes.
And we did not want people mixing that at home.
That's fair.
That's pretty unsafe to do. So we're partnering with Formlabs, who's actually going to be mixing and kind of bottling all our materials. And then this will be available for purchase, like on MatterHackers, the resin. So now you can just buy the resin pretty much at cost with all these amazing collaborators and just pour it in this machine and get it working. So as accessible, as easy to use as possible is really what our goal is here. Prusa has also been an amazing support for this. So all the 3D prints you see in here, while they'll work on every 3D printer, we're designing them to be on the Core 1, just so it's like has some sort of baseline so people understand how to make repeatable, useful prints.
Well, before we dig into the machine and kind of take a tour, if I were to go out and source the materials for this sort of machine, not taking effort into consideration for the cost, just for the materials themselves, do you have a general price?
It'll be about $1,400. As we dissect it, you'll kind of see where the price point comes from. A lot of it revolves around the projector. So finding a cheap, accessible, powerful projector was kind of hard, and that's what increases it the most. But of course, with open source, what we also expect is that as this technology grows, people are going to find shortcuts. They're going to find ways to bring this down pretty drastically.
Challenge accepted.
Well, let's take off some panels. Let's take a look at the inside because what we saw in the lab is obviously fairly different than what we're going to see on the inside here, right?
I mean, it's if anything going to be a lot simpler. We saw a lot of crazy technologies, a lot of expensive bits and bobs, and now we have something here that's using things you can buy off Amazon and McMaster and everywhere kind of on the internet.
That's
pretty
so
easy.
Cool. This is it right here. So then this side is going to be, this is the projector, right? And tell me about this projector. What specifically makes this projector good for this machine?
Yeah, there's a couple different things we wanted for it. The first one is we wanted it to be compact. A lot of projectors out there can be pretty big. We wanted it to be cheap, obviously for the accessibility build points, and we wanted it to be powerful. And luckily this projector right here is laser based, so very, very strong power at like the blue light that we're using to cure the material.
Oh, that's right, because the resin has a certain, nanometer wavelength, and then that has to project that in order to cure it. And so this does.
Yep, so it's this machine revolves around what we call 450 nanometer wavelength. So blue wavelength light is what cures the material. And that's really what we wanted for in a projector. And this has really, really strong blue light that is shining out.
Projector, check then. What's next? What does it pass through?
Well, everything's powered by a little Raspberry Pi back here. Again, not really big computational things that we need for it. All it's doing is playing a video and controlling a couple things. So it's not
oh my
a lot
God,
of
that's
things that are
right. It's
happening.
playing a video. It's a video.
No
Okay.
G-code, just MP4 files that we're playing out.
That's amazing.
And then the cool thing is, this projector's on a custom design modified from another open source project that allows us to basically move the projector in 3 dimensions, but very, very slightly using screws, and that makes it great for alignment.
Alignment is key.
So getting that image to be exactly in the little center that you want is going to be the big name of the game of getting your good prints here.
Okay.
Cal, I always say, is really good at getting really okay prints. Like, it can be super out of alignment, things can be wonky, and you'll get something that resembles it. But the more you dial in those accuracies, you can get some really great parts out of this.
Yeah, if we just take it for its base components, like you said, it's playing a video through a projector into a tube of goo. There's not a lot of complexity there.
No, I mean, like, mechanically, it's a beautiful design, especially what the students boiled it down to, is we just have a rotation element, we have some things to basically make the light a little bit more cleaner and more straight, and then we have the optical projector, and that's not much more to it.
Fairly straightforward.
And up front is your screen with a knob, and it's just running what?
That's just a little LCD screen that's attached all the way back to the Raspberry Pi. Allows you, like other 3D printers, to change different settings, whether that's playing your different videos, adjusting orientations, changing colors, things like that. Just a nice little simple interface to interact with the machine with.
The precision that you can get from something after minute calibrations, after being checked log edge, is astounding.
So they're building whole software suites in here that will help you basically align it and get things accurate and debug what's going wrong, how to improve your prints. Everything that we're trying to think of people would have roadblocks as, we're making tools to get around it. We want this to be as a seamless experience as possible, because this is going to be people's first time basically hands-on with that technology.
Right.
We don't want them to have the issues we have in the lab. We want them to find new issues to solve, which will be quite exciting.
Did any of the stuff that you did, the machine that went into Space Cal stuff, did any of that make it into here?
Some of the concepts behind it, actually. So the way we rotate the vial down there and kind of how the bearings are rough up against it, those were similar designs used in
Really?
the space. Yeah,
Oh, cool.
the space printers. Able to use some different concepts, more reliable ones,
Okay.
to make this a pretty robust printer.
This is a great proof of concept. And then this is calibrated, ready to go. Like, we could technically print something, right?
Yeah, I mean, there's not much more to it. So as you remember last time, we just make these MP4 videos.
Yeah.
As you also remember last time, it was all like our own weird software we had to go through. There was a lot of lines of code.
There was a lot, yeah.
That's being built into its own GUI as well. So there will be
Really?
a software you just download. You just throw your STL into it. You give it your printer parameters, and it'll output that MP4, making it, again, way more accessible.
All right, enough
Yeah.
talk. We should probably print something, right?
Should we print something?
We should probably print something.
Awesome. All right, I'll have to go get the resin.
Few moments later.
The resin we're dealing with today is still resin. There's safety precautions we want people to take. It's sticky. We want them to have it in proper environments when they're handling this. So
Okay.
gloves are, I would say, an absolute minimum. The other thing with this resin is quite exciting. And like I've talked about before, it's simpler than SLA resin.
Okay.
There's like 3 components. There's the base like resin, so the thing that you kind of actually form and has all those mechanical properties.
Yeah.
You have the photoinitiator, the thing that reacts to light. And then we have basically some sort of alcohol in here that makes the reaction happen faster. The resin is made to both work in these about inch diameter vials, but back here, this whole machine is designed around this end diameter. So this is a 4-inch diameter vial, and you will be able to make 4-inch diameter prints within this machine.
Huge!
But yeah, so the other thing I was saying is that this resin reacts to just natural sunlight or
Yeah.
things you might have in your office,
Sure.
and the reaction is exothermic. If you're just
Oh.
printing your part, it's fine. I mean, it'll generate a little bit of heat, but not much. But I want people to be cautious that if you like leave this vial out in the sun, it's gonna get hot. It's not gonna get super, super hot. It's gonna get maybe like 230 F. Like that's the worst case scenario if you try to cure this whole thing.
Can we do that later?
We can still do that. I just want people
I have
to
my
be safe
flirt,
around
like
it.
let's do it.
It is curing a little bit right now because we have a lot of studio light. Let me bring this around here. We do have enough for a couple prints. Okay,
Ooh.
and then we'll sometimes have to stagger it into the machine to make it a little easier to load.
Okay. Not a lot of space in there? Or?
It's pretty cramped. So I'll start it up, and now it's printing. So again, it's pretty simple. We have our specially computed videos. We're basically shining it all the way through the vial, and where that light crosses over and accumulates over time is where we get our part to form, and it only does that in the areas that we want to.
It's still magic, dude.
It's so cool.
It's still magic.
And it's of course very hard to see, but we're gonna go grab a tweezers, take it out of there,
The tweezers.
wash it, cure it, because it's a little hard to see. Cal parts are normally just a little more gradually cured. It's meant to get to that first threshold where it's slightly solid.
A
So
net near shape?
Yeah, net near shape. And then basically we'll wash it off with IPA, and then we're gonna cure it in water, because you know how it's basically flopping around?
Yeah.
If we put it in something neutrally buoyant, that's where it kind of helps regain its shape a little bit.
Oh, okay.
Sometimes your print will be solid. Again, some of the fun parts of this technology is it's tough to understand.
So if we
how
put it
we'll
in
be-
water, we could put it in the sunshine outside.
We could. We can cure it via the sun. Next, we're gonna put it in this vial and then put some IPA in there and let it clean. So instead of using harsh chemicals like this acetone or IPA or anything like that, you actually just spin it super, super fast.
Oh, okay.
So all that excess resin just flings right off it through force. And not only are you not using those strong chemicals, you can actually reuse that material as well too, because it's not being contaminated. It just flings off, it will drip to the bottom, and then you can basically let it sit and use it again.
That's cool.
It's not like the part's not cured or its mechanical properties, it's just a little sticky.
Okay.
So what we do is when we cure it in water, it helps get rid of that stickiness. a
Got
little
it.
bit.
Okay, so it just sits here now. For how long?
So if this were in a curing chamber, you would leave it for probably about a minute or two.
Okay.
With the sun, we'll probably give it about 5 minutes. We left him out in the sun and our water, and it's pretty hard right now. And you can see that like another really fun thing about this resin is that it bleaches. What I mean by that is it was really yellowy before you
It
saw
was
that
yellowy, yeah.
grab. But as it cures and is left out in the sun, it's just gonna become nice and shiny and clear. We cured it, we removed all that excess resin. It might be a little bit sticky. This guy's a tiny bit sticky, but now our parts are safe to handle. These are ones in a little bit more of a controlled environment. The one other thing I was gonna point out is you asked like, what happens if I don't stop it or why did I stop it? Then
Oh.
this is where we get our
Oh, is there a new? Oh, there's a thing.
that's where we get our little bit larger thinker. So that's one that had just a little bit too much time in the light,
Okay.
and it just kind of
Oh yeah,
overcures.
compared to the other one, I see.
Yes.
This technology obviously is evolving, and it's really cool that you brought it here. And I know things weren't perfect, but again, the goal for this wasn't to be perfect. The goal was to get this into the minds and the hearts of people who are curious about it and want to take it further.
Exactly. And there's a lot of resources for that. A big part of having a good open source design and machine is the documentation and build guides.
How's the documentation?
Beautiful.
Yeah.
The students have put so much time and effort into that, and they're so eloquently put out of basically how to build it, how to operate it, what might go well, what might not, and it's all going to be on one website.
The website where everything will be available will be in the description below, right?
Yes,
Yeah.
it'll be a very...
It'll be right. Wait. It'll be right here. Right here. We'll put it on
Right-
screen.
right
Right
here.
here. Right here.
But it'll be a one-stop shop for everything. It'll be basically the buying links for the resin, the BOM for the whole printer, and all the additional setups that will be built with it. Because like I said, we're doing some post-processing things as well.
Yeah.
That will also be open source ways to post-process it. Basically other forums to look to. And don't forget, we have the Discord. That's going to be a wonderful place basically to talk about the different ways you build it.
We said there's 2,000 people in there, right?
There's 2,000 people right now, and I only expect that to grow. And that's going to be a wonderful community, not just for talking about this setup right here, but people have been asking other interesting questions about the technology and how to grow into it and how to be
Really?
involved with it. And it will just be a really cool community and one-stop shop for everything related to Cal.
Thanks for watching. If you made this far, you're awesome. Don't forget to hug each other more, fight for cause you believe in, and OPENCAL all the things. And as always, high five. Going?
A good one.
Resin 5.